Exoplanets were discovered back in the late 1980s. Since then, the number of detected ones has increased hundredfold. According to statistics from January 2021, over 4,000 planets in other systems have already been discovered. Apart from these, several thousand candidates likely to be given this status have been registered. With sufficient evidence from Earth-based observatories, most of them are going to become officially confirmed exoplanets. The overall number of planets in our galaxy may supposedly be over 1 trillion. From 5 to 20% of these are close to our Earth in terms of their size and composition. Not all of them are in their host star's Goldilocks zones, that is, not all of them are habitable. Still, according to scientific estimates, there are not less than 300 million potentially habitable planets in the Milky Way. Exoplanets differ very much in terms of their environment. Their dimensions may be enormous, some even beating Jupiter, but there are also comparatively smaller ones, close to our Earth in size. Some of these bodies are hot, consumed with oceans of molten lava, whereas others are encased in a shell of permanent ice. There are planets out there made entirely of oceans, with not a bit of dry land on them, while on others, sulfuric acid rains or diamond snow are a regular occurrence. Various techniques are used for discovering other worlds. As a rule, it is next to impossible to spot an exoplanet by simply looking through a telescope. That is why in 2009, Kepler was launched, the first space telescope designed for searching for planets beyond the boundaries of the solar system. The telescope's cameras had 42 charge-coupled devices, or CCDs, with a total resolution of around 96 megapixels. With a field of view covering about 25% of the sky and coupled with a 1.5-meter mirror of the telescope, it was able to detect astronomical bodies within 3,000 light-years from the Earth. In the 3.5 years of productive operations, Kepler managed to spot over 3,500 exoplanet candidates. The status of over 2,000 of these has already been confirmed by repeated observations. It was in this period that the smallest of known exoplanets today was detected. The diameter of Kepler-37b is just 35.7% that of the Earth. The telescope was also instrumental in registering several stars and brown dwarfs. The transit method was used by Kepler in the search for exoplanets. This method is based on observing the star's luminosity. If the supposed planet passes between the parent star and the observer, this will be noticed in the telltale decrease in the star's luminosity. The extent of these fluctuations in luminosity directly depends on the ratio of the star's and planet's dimensions, while their regularity allows one to estimate the object's orbital period. The transit method requires accuracy in measurements. Changes in a star's spectrum account for less than 2% and are usually tenths or even hundredths of 1%.